the elastic collision of two equal weighted carts, both of them weighing 515 grams. And what I'm going to do is slide the first one through the air track, and it will record the speed. It will then hit the second one, and that then will pass through, and then we'll measure the speed on the display on the computer. So here we go at trial 1. The results from trial 1, velocity 1 of the first cart is 0.612 meters per second. Velocity of the second cart after the collision is 0.570. Notice that the first cart stopped and the second cart kept going. This is an example of a totally elastic collision. Trial 2 of a totally elastic collision. All right, and that's the results. Perfect. First cart stopped, second cart kept going. Velocity of cart 1 before the collision is 0.551 meters per second. Velocity of 2 is 0.517 meters per second. So that's an elastic collision. Next part is for the totally inelastic collision. The bumpers, they'll actually be Velcro, and they'll stick together when they collide. One is moving, 2 is stopped, and then they'll collide, and we'll get the velocity before and after the collision. Trial 1. That worked very well. Velocity before the collision of just cart 1 is 0.733 meters per second. The velocity of carts 1 and 2 together after the collision is 0.349 meters per second. This is an example of a totally inelastic collision. Trial 2 again. Cart 1 before the collision, 0.614 meters per second. And the velocity of carts 1 and 2 combined, sticking together, is 0.289 meters per second. So this is an example of totally inelastic collision with two equal masses. For this part, instead of having carts of equal mass, we have cart 1 is now almost twice as large. We've added a 500 gram weight to it. So now we have a total of 1.02 kilograms here and 0.515 kilograms here. Heavy object striking a light object. So we're going to do trial 1. That was very successful. 0.638 was the velocity of cart 1 before the collision. And after the collision, both of them sticking together, it was 0.407 meters per second. All right, we'll try that trial 2. All right, that was successful. 0.662 meters per second for cart 1 before the collision, 0.421 meters per second after the collision of both 1 and 2 together. Now what we're going to do is have a light cart hitting a heavy cart. So cart 1 will be 0.515 kilograms. Cart 2 will have 1.02 kilograms. So it'll be approximately twice the mass of cart 1. And we'll see what happens there. All right. Oh, that was very successful. 0.757 for the light cart before the collision. 0.289 meters per second of both cart 1 and 2 after the collision. All right, we'll try that again. All right, very successful. 0.612 meters per second before the collision of cart 1 and 0.196 meters per second of cart 1 and 2 after the collision. So that is a totally inelastic collision with cart 1 being lighter and cart 2 being heavier. As an example, when we're calculating momentum and kinetic energy, momentum is mass times velocity, where the mass is in kilograms and the velocity is in meters per second. The kinetic energy will be 1/2 times the mass times the speed squared. So I'll do one example of calculating momentum, like with cart 1, which had a mass of 0.515, and an example if the speed velocity was 0.70 meters per second, then the momentum would be mass times velocity would be 0.515 meters kilograms times 0.7 meters per second. And we end up with 0.361 kilograms meters per second. All right? Then kinetic energy would be 1/2 mv squared, would be 1/2 times 0.515 kilograms times 0.7 meters per second all squared. And for that, then, we would get kinetic energy would be 0.126 joules. That would be the kinetic energy for that equation. So that's how you calculate momentum. Mass times velocity, and kinetic energy is 1/2 the mass times the velocity squared.